to
Oh,
be
how
able
do
to
I
watch
change
this.
it?
Okay. You go to in Zoom, the Zoom panel,
Yeah.
and you
Oh,
be
how
able
do
to
I
watch
change?
this. Yeah, I can do it for you. I got you. Okay,
Oh, I just seen it. Thank you.
no problem. All right, so test prep. Let's start talking about some of the questions that you have here. So this question says, which of the following is equal to the sine of pi over 5? So this is a tough one if you don't know the properties, but do you remember you're taking trig? You've just probably finished trig, right?
Yeah, I'm taking pre-calc.
So you've probably done this already. Let me show you kind of a little bit of a way to cheat. If you don't know the formula, and one of the formula was that the sine of theta, sorry, the sine of negative theta is equal to negative sine of theta.
Oh.
So that's one thing. Now that doesn't actually help us with this problem. Another thing is that
So then why isn't it equal the answer B? Because the answer is C.
it's not, because this isn't negative. So that this actually doesn't apply. I misread the question at first. But another thing that you'll remember is that when you're finding sine and cosine, if pi over 5 is right here, and the sine of remember the sine is your y coordinate. You remember that?
Yeah. And
So
cosine.
that's this distance right here. So this distance is the sine of pi over 5. And so over here, distance will be the same. So that will be equal to the sine of pi over 5 as well. But this angle right here is pi over 5. You get what I'm saying?
Not really. Wouldn't it be like 4 pi over 5?
Well, no, I'm telling you that this angle is pi over 5, the reference angle. So this full angle right here, you're right, is going to be 4 pi over 5. Okay. So that whole angle, this whole angle, like you just said, good job, is 4 pi over 5. So the sine of pi over 5 is equal to sine of 4 pi over 5. But that's not one of my options. So now you have to figure out, well, what's 4 pi over 5 the same as? So let's see. Okay, so I'm trying to think of how they expect you to do this problem so I can explain it to you. You could also think of it like this. One of the other properties is that the sine, oh, they're explaining it. Yeah, that's what I was just going to explain. The sine of an angle is equal to the cosine of the complement of that angle. And the complement of that angle is going to be whatever 90 degrees minus that angle is. So let me explain that to you again. So that's how they want you to do this problem. So do you remember how you have a triangle? Triangle right here, and I have an angle right here. Let's say that this angle is pi over 5.
Yeah.
And this side over here is the opposite, right? And this side here is the hypotenuse, right?
Mm-hmm.
And this side would be the adjacent to pi over 5, right? Well, if I put this angle in right here, which is going to be the complement of pi over 5, right? So that angle is going to be whatever 90 degrees minus pi over 5 is what that angle is right there. You understand what I'm saying here?
Oh, I do.
So
But
this angle would be 5 pi over 10 minus 2 pi over 5. I'm sorry, 2 pi over 10, which gives you 3 pi over 10. So this angle is actually 3 pi over 10. That's that angle. And now the opposite of this angle, the hypotenuse is still the hypotenuse, right? The opposite, or I'm sorry, the adjacent of this angle, the adjacent of this angle is the same as the opposite of that angle, right?
Right.
So that means the cosine of this angle is equal to the sine of that angle. So that's what I'm getting at here. The cosine of 3 pi over 10 is equal to the sine of pi over 5. That's always going to, and in fact, that's why it's called a co. You know what co stands for?
I think like together, like coterminal,
It actually
cotangent.
stands for complementary. The cosine of one angle is equal to the sine of its complement and vice versa. Do you get that? I'll say that again. The cosine, let me give some simpler examples so you get what I'm saying here. Can I create a new slide here? I'll go on the next slide.
Okay.
The cosine of 30 is equal to the sine 60. The sine of 20 is equal to the cosine of 70. You get what I'm doing?
I do.
The cosine of 1 is equal to the sine of 89, and so forth. In fact, that also happens for the secant 25 equal to the cosecant. Do you hear it? Cosecant
Yeah.
of 65. That's why it's called the cosecant, because they're complementary functions.
Oh,
That's what they are. Because look, just think about it. If you have your triangle right here, and you have this angle, and if it's a right triangle, and you have this angle here in blue, it's going to be the complement of the angle in red, right?
right.
Complements of each other. And isn't the sine of the blue one the opposite hypotenuse? Isn't that going to be the same as the sine of the red one? Because that's going to be the adjacent. Whatever the opposite of the blue one is the adjacent of the red one, if they're complements of each other. And that's
Okay.
why that works. And so it also works for tangent. Tangent of, let's say, 40 is equal to the cotangent of 50. So that's the idea that they were trying to get at here. Now, if you notice that right away, you would have been able to say, oh, it's going to take, see, I didn't notice it right away because I misread it, but I that was kind of the property that they were checking if you understood. Now, you didn't have to do it that way. You could have taken your calculator out and you could have just punched them in. Sine of pi over 5. And if you're quick at this would be just as fine to do. Sine of pi over 5, pi divided by 5, hit enter, and then just punch in the other ones. Negative cosine
This
of
is
pi over 5.
the
This
non-calc.
was was this a non-calculator portion right here?
Yeah.
Oh, I didn't even know they did that with the SAT. They have non-calculator portions?
Yeah, they have both.
Oh, okay. The ACT didn't have that.
Oh.
Okay. But that's how that works. Okay.
Okay, that makes sense. I did have one question though.
Yeah.
So is there like an inverse proportion like to that? So would cosine of an angle like kind of like just
Uh-huh.
switch these two
Yep.
things?
You see how I switched them? The sine of an angle is equal to the cosine of its inverse and vice versa. See how I did that? So the sine of 70 is what you're saying is equal to the cosine of 20.
Kind of like the equation of like, could it be cosine of an angle equals sine of 90 minus pi over 5?
That's what they're saying right there. This is kind of a technical way of saying it. It says they are co-functions. Remember how I said sine and cosine are co-functions? What that means to be co-functions is that the sine of one angle is equal to the cosine of its complement.
Okay.
The cosine of one angle is equal to the sine of its complement. So these two have to add up to 90. Got it? And that's kind of the point that I'm making here.
Got it. That makes sense. I guess I was wondering, like, would I need to know just all the trig equations then?
It's good to just, here's the thing. You don't really want to necessarily memorize the trig equations because that's hard to do, but you want to understand the concepts of those equations.
Okay.
That's what you want. You want to understand deeply the concepts. That's what the SAT does. The SAT write those tests so that you can't just memorize a bunch of things. I mean, you could, I suppose, but it'd be really hard to memorize everything that you need. They don't want you to memorize it. They want you to understand it. And the questions that they ask get at your understanding of it. Get what I'm saying?
Okay.
The way that they ask the questions get at your understanding. So what is the product of the complement or of the complex numbers, this and this? So this is just basically, you got to multiply those together, right? So this is just one of those problems where you just have to multiply it together. There's really not a shortcut way of doing this. But you remember how to multiply these together?
Yeah, like factor it. Yeah.
You're foiling it out. So it's negative 18. I'll color code it for you. Positive 3i. Positive 24i. Negative 4i squared. But now we have I squared. And you remember how I squared equals negative 1?
Oh, okay.
You don't remember that, I'm telling you. I don't know if you've learned that yet. I think you did learn that last year.
I
Okay.
don't know. Okay.
So I squared equals negative 1. Just remember that. See, if I square this, I'll get negative 1. Again, that's a concept that you have to understand, imaginary numbers. And then negative 1 times negative 4 is positive 4. So now I'm going to add like terms together. There's a negative 18 and a positive 4. Negative 18 plus 4 is negative 14. And there's two imaginary components or terms. So 3i plus 24i is 27i. So there's your answer.
Wouldn't it therefore be like, technically, if you were to simplify it more, negative 14, like, plus the square root of negative 27 or something?
No,
Okay.
we don't simplify. This is the way they want you to write it. We don't simplify it more than that.
Okay.
That's the simplified version. Okay.
Okay.
Make sense?
It
All right.
does.
So go ahead and practice those other things on your own, and keep adding, questions to the Jamboard, and we'll go over them.